Hello everybody, this is class 12th mathematics chapter 6 applications of derivatives. This is the first video which I am introducing on this chapter. This is the first video on this PDF. I shared you this PDF in the WhatsApp. If needed again you can ask me so that I can share you. Phone number is 720-4700-173. To that phone number if you message I will send you the PDF related to that. Okay, now in this session, in this video you are going to see, let us a little introduction on applications of derivatives. What are there in applications of derivatives, what concepts are there, also we see that what concepts we are going to discuss. So this chapter is completely very important topic for the examination point of view, because from this chapter in the final board examinations you are going to get a 6-marker question. You see, I have written here in the applications of derivatives particularly, I have written here introduction. In this chapter we have to discuss 5 concepts. One is rate of change of quantity, errors and approximations, tangents and normals, increasing decreasing functions, and the last one is, last but not least, maxima minima. So what are the 5 concepts? These are the 5 concepts we have to discuss. But the thing is, like, due to some particular results, you know very well about this year the CBSE has revised the syllabus. CBSE has cut some topics for 2020-21. As for the received concepts, I can say that these two topics, first 2 topics, you can see the first 2 topics were deleted from the examination point of view. If you want to learn, if people are showing the interest to learn, you can learn these 2 topics, but from the examination of point of view they have deleted. If they give again a revised syllabus, if they put these topics again, I will discuss them. But right now I am not touching those 2 topics, which are rate of change of quantity and errors and approximation. I am touching only these 3 topics, which is tangents and normals, increasing decreasing functions, and maxima minima. These 3 topics only I am touching. So in future, if CBSE is revising a new syllabus and they are giving these topics, means I will discuss them separately. Right. So as of now, as for the information available, we have to discuss only tangents and normals, increasing decreasing functions, and maxima minima concepts for this, from this chapter. Okay, so from this chapter, tangents and normals is the first concept which I am going to discuss. In the textbook order, if I see, in the textbook order they gave increasing decreasing functions first, tangents and normals next, maxima minima last. But I am going to discuss in a different order, which is first I am going to discuss tangents and normals, then increasing decreasing, then maxima minima. In this way, if you are learning, you will be understanding it properly, right? So first concept, what is the tangents and normals? What is a tangent, what is a normal? First of all, what is a tangent? Tangent is a, if you take an echo like this, it is y is equal to f of x, and this is y axis, x axis. And you remember, the tangent is a line, straight line, which touches the curve at only one point. This is called tangent. Like in 9th standard and 10th standard, you have tangents to a circle. So that means tangent is a line which touches the circle at one point. Do you remember? So in that way only, same way here, instead of the line, we have a curve like this. So on the curve you take a point P. At P, if you draw a line which touches the curve at only one point, that is called tangent. This is called tangent. And at that point P, if you draw a line which is perpendicular to tangent, this is called normal. What is this? This is normal, and angle between the tangent and normal is 90 degrees, and this point P is there. If you see, look at this point P, and this point P is called point of contact. Okay, this is the point P, which is called point of contact. Most of the times we take the point of contact as x1 comma y1. Okay, this is very important thing you should remember. Thank you very much. See, if you see, that is the diagram I have taken here. Y is equal to f of x is the curve. Let me minimize it. Y is equal to f of x is the curve. This is the curve which you have taken. Then this is the tangent, and this is the normal, and the point P, which is P, is there now. P is called point of contact. This P is called point of contact. And here is the point x is equal to A I have taken. That time x coordinate of that point is there now. Point is called is A, and sometimes they may give you y coordinate also. You can take B. Sometimes the point of contact, sometimes not, most of the times point of contact I assume as x1 comma y1 instead of AB. we can take x1 y1 also. So that P is called point of contact. Point of contact is always we denote with x1 y1 unless otherwise they state, they give. If they don't give, we take the point of contact as x1 y1. But now this is the tangent and normals concept. I have explained you what is a tangent, what is a normal, how this is related to derivatives concept, why it is kept in applications of derivatives concept, where we use derivatives concept to find out these tangents and normals. Look at this, see the thing is like very important thing to find out equation of line. In 11th standard you had a concept which is called to find out the equation of a line, you need a slope. You need its slope. What you need? Slope of the line is needed. So to find out the equation of the tangent of or whatever it is, you need the slope of the tangent. Similar way to find out the slope of the normal. If I have to find out the slope of the normal, if you know the tangent slope of normal is very easy, because by using the concept in 11th standard, which is product of the slopes is -1 when the lines are perpendicular. Because if I take m1 is the tangent slope, m2 is the normal slope, the product of their slopes is -1. That means if m is the slope of tangent, -1 by m is the slope of normal. So to find out the equation, this slope is very important. So we need to know how to find out the slope of the tangent before we find out the equation of the tangent. Before we find out these equations, we should know how to find out the slope. So to find out the slope of tangent only, we use the derivatives concept. How I am using derivatives concept? Look at it. See, to find out slope of tangent at y is equal to f of x, at x is equal to a, is m is equal to dy by dx at x is equal to a. That means whatever the curve is given now, you find out its derivative. So for example, y is equal to x cube is given. What is dy by dx? 3x square. So x cube curve will be something like this will be there. See, the curve for x cube will be like this if it is there. So at 2, if I wanted to draw the tangent will be like this. Let me draw the tangent. This is the tangent at some point. So the slope of this tangent will be 3x square. But what is the point? X value, if you know that x value, if you substitute at that particular point, you will get the slope of the tangent. So whenever they ask slope of the tangent, you do find out dy by dx of the given curve. Dy by dx of the given curve. So to find out the slope of the tangent of any curve, y is equal to f of x, first step is you will have to find out dy by dx. It is very important. Try to remember. So some questions if I discuss, I will understand more. So and they will ask you to find out the slope of the tangent. Whenever you find dy by dx, you get answers like this, variables 2x plus 3, and separately the values of x will be given. The values of x will be given. When you are given with implicit functions and all, your dy by dx will be like this. Sometimes -2y by 3x like this will come. That time both x and y values also will be given. That is called point of contact. 1, 2 like this will be given. So whenever you substitute this x and y values in this dy by dx, you get the slope of tangent. So that means x is equal to 1, y is equal to 2. You have to substitute since the point is given as 1, 2. So that means here the two things is very important. To find out the slope of the tangent, to find slope of the tangent, the very first thing is you should find out dy by dx. When you get dy by dx as some answer m, in that you have to substitute the x and y values if the variables are present in the dy by dx. After substituting only, you can take it as m, which is called slope of tangent. So very important thing to find out the slope of the tangent. Very important thing, you need to differentiate the given curve. Given curve, CURVE. Given curve equation must be differentiated to get dy by dx. In that dy by dx, if you substitute the values of x and y given, then you get the slope of the tangent. So try to understand, because I am stressing more, I am explaining more. Reason is the slope is very important concept in this. So to find out dy by dx, first find out dy by dx from this, then in that put x value is equal to a. Sometimes here one more definition I have given, you see this one. Sometimes involvement of x and y both will be there. That time also you find out dy by dx. That time x1 and y1 both the values you will have to substitute. That means you get the dy by dx as 2x plus 3, then x is enough. This is enough. If you get dy by dx as some 2x plus 3y, this time x and y both are required. That time I use this one. Okay, understood? Right. Now look, slope of the normal. Very easy. Slope of the tangent. If you understand the slope of the tangent, how to find out here and here two are there. If you see slope of the tangent, two formulas are there. One is dy by dx at x is equal to a. One is dy by dx at x1 is comma y1. Means here only x value is given. Means this one x1 and y1 is given. Means both x and y values we substitute. Both are same only. Okay. So whenever you get the slope of the tangent, which you assume as m, what we assumed, we are letting as m. So then slope of the normal will be minus 1 by m. Remember, what is the slope of the normal? It is minus 1 by m at x is equal to a, or at the point x1 y1 whatever it is. The slope of the normal is always taken as minus 1 by m, where m is the slope of the tangent. What is m? M is the slope of the tangent. Remember, if m is the slope of the tangent, then only you have to take, if m is slope of tangent, then what is slope of normal? Minus 1 by m. That is slope of normal. Remember the formula. Okay. Then now the very important thing, how to find out the slope of tangent. That's what I am explaining a lot many times. I explained once again. Find dy by dx for the given curve. Substitute the values of x and y to get the slope of the tangent. Once you have given with a curve equation, the curve equation must be differentiated to find out dy by dx. In that curve equation, after finding dy by dx, you get an expression. In that expression, x and y both are there. Means substitute that x and y values to get the slope. That is m. Okay. Now once again, that's what. Now example, let me explain this one with an example. Find the slope of the tangent and normal to the curve y is equal to x cube minus x at x is equal to 2. So whatever the question which is given with a curve, very important thing is you will have to find out dy by dx. Remember, so you know very well, for the derivatives concept already you had practiced a lot. So y is equal to x cube minus x, right? What is dy by dx? Which is 3x square minus 1. So slope of tangent is equal to m is equal to 3 into 2 square minus 1. How we got this one? See, if you see, it is 3x square minus 1. So what is the value of x is given? 2. So that x value substitute in this. Then 3 into 2 square minus 1. Then 12 minus 1, 11. So that is slope of the tangent m. I told you, very first given curve equation, you take the given curve equation. See, very first you take the given curve equation. Then take the given curve. Very first you take the given curve equation, then differentiate on both sides, then substitute the value of x in the derivative what you got, then that is called slope of the tangent, that is 11. Once you get the slope of the tangent, the slope of the normal formula is minus 1 by m. So the answer for the normal is minus 1 by 11 is the slope of normal. See, look at this, slope of normal is equal to minus 1 by 11. So minus 1 by m is the slope of normal, as I assumed m is the slope of tangent. Hope you understand how to find out slope of a tangent and normal to the given curve at the given point. Next question, same type, look, but implicit. Find the slope of the tangent and normal to the curve x power 2 by 3 plus y power 2 by 3 is equal to 2 at 1 comma 1. How to find out the slope of the tangent and normal? So given curve is x power 2 by 3 plus y power 2 by 3 is equal to 1. What is the given curve? You take that given curve first, then differentiate with respect to x on both sides. Then it is 2x power minus 1 by 3 plus 2y power minus 1 by 3 into dy by dx is equal to 0. So what is that the derivative 2 by 3 x power minus 1 by 3? How we got it? Means 2 by 3 x power minus 1 by 3. How we got it? Means apply the formula n into x power n minus 1 and do it and check it out. You get it like this only. Okay. There is a doubt, means in this how to 2 by 3 x power minus 1 by 3 we got it, means make a pause and do it on paper and check it. Okay, so the derivative differentiating on both sides, you get this one. So here dy by dx because of chain rule. So what is the dy by dx value after simplification? We get the minus 2 by 3 x power 1 by 3 by minus 1 by 3 by 2 by 3 y power minus 1 by 3. That one we get it. Minus 2 by 3, 2 by 3 cancel. Minus of x power minus 1 by 3 by y power minus 1 by 3 can be written as y power 1 by 3 by x power 1 by 3, which contains minus, because the minus will be reciprocal to the numerator. Denominator will become numerator, numerator will become denominator because of the minus in the exponent, which is nothing but cubed root of y by x, minus cubed root of y by x. But they are asking us to find out the slope of the tangent at the point 1 comma 1. So 1 comma 1 substitute, x is equal to 1, y is equal to 1, substitute 1 comma 1 means x is equal here, y is equal to 1. Y is also equal to 1. So it is minus cube root of 1 by 1. The minus 1 is the slope of tangent. Minus 1 by m is the slope of normal, which is 1. Next. This is a different kind of question. This time they are not given a point. They are asking you to find the point in which the slope is given. Slope is given. They are asking you to find out the point. Earlier in the example 2, I have given you the point and I asked you to find the slope. But here slope is given. I am asking you to find the point. So when the point is given, slope we found. But here the slope is given, we should find out the point. So like how to find out? First, whatever the question given curve equation, you write down first. Differentiate on both sides. dy by dx is equal to root of 4x minus 3 derivative 1 by 2 root 4x minus 3 into 4 from where? Chain rule. 4x minus 3 ka derivative which is there inside. Minus 0 1 derivative is that. So it is 2 1s are 2 2s are. So you get 2 by root over 4x minus 3 is dy by dx. Now we have to find out the point, no? So that point of contact you take as x1 comma y1. Therefore, hence the slope of tangent will be 2 by root over 4x1 minus 3. Because the point of contact is x1 y1. So the slope changes to 2 by root 4x1 minus 3. Because once you find out, so substitute the point of contact, then only it becomes slope of tangent. So but given slope is 2 by 3. If you look at the question very carefully, given slope is 2 by 3. So the given slope, what I got, the slope is 2 by root over 4x1 minus 3. Given slope is 2 by 3. So equate both of them and solve the equation. Then you get x1 is equal to 3. Solving the equation steps you can understand by looking them. So if x1 is equal to 3, you have to find out the y1 because they are asking the point. If you see, they are asking point. When they ask point, x1 comma y1 is the point, but I got x1 value only. What I got? Only x1 value. How to find out y1 means, remember the x1 and y1 is on the curve. X1 is on, y1 is on the curve. If you look at the graph, see the point of contact wherever it is there, that is on the curve whatever it is there. So that point of contact must satisfy the given curve. Given curve equation is, look, what is the given curve equation? This is, so then I can write y1 is equal to what I have can write y1 is equal to root over 4x1 minus 3 minus 1, because x1 y1 is a point on this curve. Since x1 value we got 3, substitute to get the value of y1 which is 2. Therefore required point is 3 comma 2. Required point is 3 comma 2. With the 11th standard knowledge, you can find out the equations of tangent and normals. Now equation of tangent to the curve y is equal to f of x at the point x1 y1 is, first to find out the process I am telling you, first to find out the slope by using this. They give the point, no? Using that find out the slope which is called m, tangent slope. Then therefore equation of the tangent formula is, try to by heart, y minus y1 is equal to m into x minus x1. What is y1, x1, m? X and y variables, you should not touch them, they should be like that only. y1, x1, m only you should know. What is y1, x1 and m? Means those are x1, y1 will be the point given to you, m is the slope you are finding. So substitute them to get the equation of the tangent. The important which is you should remember the formula for the equation of the tangent as y minus y1 is equal to m into x minus x1. Similarly, if you get equation of a normal as y minus y1 is equal to minus 1 by m into x minus x1, because when slope of tangent is m, slope of normal will be minus 1 by m. That's what I was telling you. So this is the equation of normal. So to find out, for finding the equations of tangents and normals, and to do more questions related to slopes finding and finding the points when slope is given, finding the slope when point is given, finding the equation when slope is given and point is given. So all those things we discuss in the next video, video number 2. More details on tangents and normals we discuss in the next video, video number 2. So thank you very much everyone. Thank you very much. Have a nice day. Thank you very much.